Started, guys. We have seven problems. Bind string of length and they each perform exactly one operation. The following and this is an occurrence of binding string and there it said. Will he remove the last zero? And will the other guy remove the first one? First zero, last one. First zero, first one. First zero, first one can be a guess. Maybe this is it. I'm just skipping first zero and first one and then I'm just putting it. How to argue though? It's first zero, first one the answer. It has less solves. I don't want to waste it. I want to prove it. If you're removing first zero, some ones can come forward, and that's the best thing that you can do to make it large. Right? To remove first ones is what you can make it to make it small. Right? So yeah, it's perfect, I think. Let me just submit it. Maybe the queue was slow, that's why it was less submissions. Okay, what is an invariant? See, if you see the operation, an in between element, you can just compress two things. And if this thing gets applied again, it still holds that you chose three things, you grouped them, and then you made something lesser. So the problem becomes, is it possible to group things such a way that you have to group some things, club some things into one value? Finally, some things might become one value, right? And then, yeah, such that minimum and maximum is this value. So, which is nothing but, can you group elements of A into elements of B? One thing is n should be greater than or equals to m, and then if you see them in the arranging order, you can greedy just works. You see them in the increasing order, you have to take something less than or equals to before this, and something greater than or equals from then you have to take something greater than or equals to before that. Greedy just works because each of them is getting some group of elements, right? If you have sorted them. And I think greedy just works. Have something less than that, something greater than or equals to that. Something less than or equals to this, something greater than or equals to this. Because this is smaller, I think you can just sort them. So yeah, greedy just works. I don't wanna be someone else. Mm-hmm. Sort both of them. Find something less than or equals to this. Find something greater than or equals to this. I have too long nails to write code quickly. You're not able to find something less than this greedily. Now you are able to find something less than this. Now your goal is to find something greater than or equals to this, okay? So now you have actually found something greater than or equals to this too. Right. So that has been assigned to this, and then you will go to the next j, and then the I will start from there. If something else is left in the A, you can definitely put that onto this. I don't wanna be someone else. I don't wanna be. Fuck, greedy doesn't work. I don't wanna be someone else. Greedy works, but you have to be careful. You're removing this from the array. You need not put all of them. The algorithm is for each thing you should be able to find something less than that and something greater than that. Something less than that, something greater than that. Anything less than this will work. And then something less than or equals to this, and something greater than or equals to that. Keep doing that. That works. Why am I getting stuck here? Something less than this, and then okay, for this something less than or equals to that, assigning is the best. And then you want to assign something, if I'm looking at the minimum element, you want to assign something greater than or equals to this too, which is best one. Now the next thing needs something less than or equals to that. And this thing needs something greater than or equals to this. Whatever is the next minimum, just give that to the next thing. And then whatever is the next minimum, give that to the next thing, and so on. And then whatever is the next minimum, give that should be greater than or equals to this. Is that the solution? So what I'll do is I'll take the minimum thing, okay? minimum should be less than or equals to this, right? I think there is definitely an easier solution, but I'm not getting it. Oh, they are distinct numbers. This will simplify. I was mostly worried about equal. Okay, now it simplifies quite a lot. First minimum thing should be less than or equals to first minimum things, and then you should be able to find something greater than that for everything. So now everything got a minimum. Okay, everything got a minimum less than that. Now from here, everything should get a maximum. There are distinct elements. Like what was annoying me was equal things was annoying me. Yeah, what was annoying me was like equal values were the things that were annoying me. But then equal values doesn't exist yet. I have to pay attention to the problem. I think I have to pay more attention to the problem because they are distinct. All of them will get actually two things. Because they are distinct, all of them will actually get two things. Now each of them should get something bigger. This is greedy itself, but you have to be careful. I was mostly worried on what if something becomes equal to something else. But yeah, that doesn't happen. It's like simple if you just try to do greedy, like something should be less than this, and then if you see this should get something bigger, this should get something smaller. This needs bigger thing. This needs smaller thing. Giving the next smallest to this might be the best thing you can do. I don't wanna be someone else. I don't wanna lose this hunger. So you need something less than the first thing, which is greedily like giving the smallest thing. Oh, that can give a wrong answer, huh? You're given an array of length 2 and each integer from 1 to n occurs exactly twice in array. Initial score is 0. See, we have to just read the problem well. You can repeatedly perform the following operation while array A is empty. Choose an integer x that is present in A. Let L and R be the indices of the leftmost and the rightmost occurrence of x in the current array, respectively. If x occurs only once, then L equals to R. Add this to reverse code. Delete the elements from AL to AR from A. The remaining elements are concatenated without changing their order and reindex from starting position from 1. Find the maximum possible score. If you have 1, 1, 2, 2, I think that's the best thing you can do, right? And if there is only one occurrence that can ever only give you uh, score 1, right? Because L equals to R, and then it's never beneficial to remove it. So finally, we'll remove the single ones. Until then, we'll try to remove the pairs. Okay? And all the single ones will give you only 1, 1, 1. So it's all about the pairs. How many pairs you can get out? How many pairs you can get out? And the pairs should not match. See, the problem is quite obvious if you see the score. Score is like number of pairs because the remaining things are just one, right? Number of maximum pairs score you can get out of it. Okay? Maximum pair minus 1 you can get out of it. I don't wanna be someone else. And if you see how the pairs will form, once you make this pair, you cannot pairs will not intersect because that will be gone. So pairs are like disjoint. That makes it even simpler. And if the pairs are disjoint, what is the maximum scores of pairs you can get? You don't want the maximum scores of pairs, you want the maximum score of pairs minus 1. That's what you want. Okay? The pair score minus 1 because that's the contribution of that, right? You can write the total score as 1 plus 1 plus 1 plus 1 per n plus for each character if it is contributing as a pair square minus 1. So now if you see that like number of pairs you can take minus pair score minus 1, pair score minus 1, pair score minus 1 up to so on plus 1. So you have to just get this number of subsequences pair score minus 1's answer. And for that how would you do? Uh, if you have the pair score minus 1 answer of the previous thing, and once you know this, the DP is quite simple. It's like pair score minus 1 previous one answer plus this minus this previous value pair score minus 1 answer plus pair score minus IDX minus 1. Quite simple problem, direct problem. If you see the score for what it is, it's quite direct problem. I don't wanna be someone else. I don't wanna be. Oh, oh. So we just kept left index and right index of everything. Now we will just form the dp. Okay, if L of, let me just take the value to be x again. If this is the left index, uh, dp of I equals to dp of r minus n is the first thing, and if this is the left index, continue. Else you have something better you can do. You can involve this and then that's something better. And if you involve that, what the fuck do you get is dp of I equals to maximum of dp of I comma, and if you take its pair, what are those pairs value? I'll just call them as uh, 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 lx equals to l of x, or x equals to, or x is I, but fine, I can write it out of x. uh, and then it is rx minus lx plus 1 times of rx minus lx plus 1 minus 1. This is what I want to maximize, plus dp of lx minus 1. I don't wanna be someone else. Int answer equals to dp of n plus n. See out answer. I don't wanna be someone else. Fuck! Why the fuck is it failing? It's so annoying. Like 1 minus 1, 1 plus 1 whole square is 2 square. It can't fail. I don't know what's happening with me. It's so simple of a problem. One, and then why don't we have 2n? Ooh, I can hear you now. We both know that deep down, the feeling that there's deep down is good. If I can see through walls, I can see you faking. If you can see through walls, you can see your faces. Safe in my rental, everything sucked back then. And I'm singing it bad, but let me be. Okay, here the value is supposed to be 10. That was right. Here the value is supposed to be 1, 2, 3, 4 square plus 1 square, right? No, it's supposed to be just 4 square. How is it coming plus 1? Oh, oh. I have to be careful regarding the cost. When you remove that, this won't contribute 1 finally. Only the in between ones will contribute to the 1. So the cost of removing this is Fuck. It's not that direct. The cost of removing this is. I assume that everything inside is like individual. Okay, if you just try to do brute force DP, if you're never removing it, it will contribute to one, and then you have DP of I minus one, right? Or if you're removing it, I think I was overcomplicating it. Either you're never removing it or you're removing it in the problem. That's the DP, right? If you consider answer till here, answer till I, you're not removing it at all, or you're removing it. If you're not removing it at all, then you can take one from there, and then in the optimal solution, you're not removing it all, or you're able to remove it. Okay, if you're not removing it, if you're able to, if you're removing it alone, if it was left out, it will give a bigger answer. Otherwise, you're removing it alone, means like you have 1 plus dp of I minus 1 is one possibility. Or if you're able to remove it with its pair, that's another possibility. And if you're able to remove it from its pair, you wouldn't remove anything in between, right, before that. So in that case, the answer would be this. And then the brute forcing answer would just be this. So I think I was thinking more. A direct brute force was good enough. I was trying to see the sum in a nicer format. Even that is not needed. You can directly brute force all the possible cases, it seems. It's even more direct. I was trying to see it in a nicer way, but it's not even needed. You're given two binary strings SNT of both of length n. For two binary strings A and B of the same length, the pair A comma B is called good if both strings can be made empty by performing the following operation 0 or more times. Choose a non-empty set of positions. It's a subsequence set of positions and a character C. Let x equals to the string of these things. Character C must be a mode of both x and y. So it should be the highest occurring thing of both. So yeah, you have to solve this problem in two levels. The first level is like when is it possible, and the second level is for all subsequences how can I answer, right? So first you have to make this complex thing of removing subsequences with modes, choosing a character, how many ever times you can do, to something simple which is answering it directly. Like so you have to just get it into some small conditions and then be able to answer it directly very quickly. First things first, if mode of both is same, then you are done. Means one is dominating in other, like then you're done already. So now let, without loss of generality, let this be dominating ones and then this be dominating zeros. Okay, you have more ones here, you have more zeros here, and each time you remove something, okay, how the fuck is it possible to remove something that is having the higher thing? It seems to be not possible, but then yeah, I would have had to think a bit. I'm sharing the screen, right? I'm streaming the video, right? What happened to my Chrome? Yeah, I am streaming the video. Everything sucked back then, back then. I thought that I should sing some other easy song, not this difficult one. For me, I think, yeah. If both of them has same mode, then it's done. Okay. Now, now if you see in the indices, okay, you have 1 0, you have 1 1, you have 0 1, or you have 0 0. Okay. In each operation, these things will not. Okay, these things can make 1 as the mode. These things can make 0 as the mode in both of them, right? And once you have many ones, and once you remove these two also, you involve them and then you remove. Only then the number of ones are reducing here. Finally, let's focus on ones because uh, if number of ones in both of them becomes equal, then you're done, right? So one of them is having more number of ones, and only when you remove these things, you will get uh, number of ones to be equal. Okay, and to remove this one, to remove these two things, okay, to remove this and this, to remove such indices, those are the ones that are causing the problem, right? One zeros. And you have some zero ones too. But there will be an excess of one zeros. Okay, there are some excess of one zeros. This and this, they can be clubbed together, like this 1 0 and this 1 0, they can all club together and they will all be having equal number of zeros and equal number of ones. They can always be removed. Okay, equal number of zeros and equal number of ones can always be removed because their mode will be the same if they have equal number of counts. And now the problem is this 1 0s, like how the fuck will you remove those 1 0s, the dominating ones? And to remove this 1 0, you have to add at least these many 0 0s and make it the excess ones. And adding 0 1 is useless anyway, because if you add that to make this equal, the other 1 0 will pop out, right? So 1 0 can only be saved by either 1 1 or 0 0. Everything sucked back then, back then. Okay. And then if you add one more 1 0, it's useless. So it's like number of 1 1s. I think it's always better to remove this 1 0 with 1 1 or 0 0 because that's the best thing, I guess. Clubbing together is useless, I guess. Because you can only remove 1 1 0 by using 1 1 1, right? Because if you for this 1 0, this 1 1 is needed. It makes both of them, because if you involve another 0 0, it's making it worse again. Because again they will break because the characters will become equal and then this 1 0 will dominate. If you add more 1 1, that's also useless. So it's like, is number of 1 1s comma 0 0s greater than or equals to excess 1 0s? This is the question. That's it, the question. If this is there, then you can remove that 1 0 using this 1 1, and then you can remove the other 1 0 using 0 0. Like that, you can remove all of them. Excess what is excess one zeros? Excess one zeros is nothing but mm, yeah, absolute of like 10, count of C10 minus C01, like absolute of this. And what is this? Yeah, count of this, is it greater than or equals to count of this is the problem. Everything sucked back then. I thought that I was dreaming when you said you loved me. Start of nothing. Ooh, show me her. So I want count of one ones and one zero zeros, and I separately want count of 10 and count of 01. Okay. So what will I'll just make three things. Int C01 of n, C10 of n, C XX of n. You guys should see that the problem is about just seeing the problem well, as like all other problems in general that we see. Now I'll just make them prefix array. Two easy problems, like why is it at D? Like this was much easier than B for me because I was not able to prove it. Here I was able to easily prove it. Have I proved it well? I think I have proved it well because to reduce this 10 you need 1 1, and if there is 10 that is bad, making it worse. There is 1 1 that helps, but that helps more, but that could have helped some other 10. Our goal is to remove excess ones, right? Everything sucked back then, back then. Why don't I get another song to sing? I'm not getting another song to sing. So now what should I do? C out, get some of L comma R comma CXX greater than or equals to ABS of get sum of L comma R comma C10 minus get sum of L comma R comma C01 means yes, else no. Is that the problem? Just prefix sums. I thought that I was dreaming when you said you loved me. I did L minus minus comma R minus minus in my mind. I don't know why I haven't done it here. I don't know why these problems are so easy. Like, there is nothing like I didn't even feel good for solving this shit. I don't know why I struggled on B, but it's time for E, F, and G. If I can solve, we're given three integers nm and d2 arrays. The array P is strictly increasing. We have to pay attention to all of them. One of them is strictly increasing. For a binary array A of any positive finite length, so modulus of A need not be equals to n. Define its value f of A using the following pseudocode. Function takes A, two parameters are the v0, two variables are the v0 equals to v0 c0, and then from 1 to n we are iterating over its length, and if A of I is equal to 1, then binary array. If it is 1, you will do uh, d is a constant, you will just do v plus d, c plus 1. Else you will make c0, c will be resetted. So what is happening here? For each length, if it is 1, v is getting added d. So v value at any instant will be like number of ones so far. And c is becoming 0. C is becoming plus 1. See, we will get scared of this without even reading it, because but it's e. I have solved so many e's, and I can solve d1 e's too if I just try some time. From j equals to 1 to m, if c is equals to p of j, this increasing value. Now we iterate. Okay, after that we have at each point we have some v value of v, some value of c, and then what do? We will iterate, and then if c becomes, and if we reach the c, then we do v plus equals to r of j. So if c matches with something, okay, it can only match once because it's strictly increasing. P is strictly increasing. It will only match once. If it increases, if it matches sometime, we will add r of j too. And if c equals to n, c becomes 0. And p of i's values are like less than or equals to n. So c keeps increasing sometimes, c keeps increasing, and return value of v. So what is happening to v? Uh, for each one d will be added to v. Only additions are happening to v. For each one d will be added to v. Okay, and mm, and c is increasing, and sometimes for some indices only one something can also be added. Sometimes, because if c was this, sometimes even if a of I is 0 or 1, sometimes if c is matching something in the p, then also that will be added to v. Okay, this is a fixed value. You can ignore that completely because that's fixed based on number of ones in I. And the other thing is, here it became 0 one more time, and if it became 0, it will again not be equal to anything. I think it's given like it's a complex thing, but I think it's we have to just little bit work, simplify things, and then just submit the problem. I think it's not that difficult. I hope. Subscribe, guys. Like subscribe to my videos, subscribe to my channel, and also see my beautiful videos. That animations I make are not easy. Like it's me who is making them. Like I'm not hiring someone else to do that shitty work. Because I like to do that. So it's a nice problem. Given pi and r of I, no, n is just a bound. N is just a bound on the values of p of I. N is not max, but n is a bound. R of I values are very different. By making it some zeros, you're losing some plus d's, but you have to add something else which is greater than d and make it work. Okay, what is I of a first? F of I of a is d of d times n. I think I have to hurry in getting some. It's not difficult problem, but you have to do some work. And then c is 1 initially, and then c will be 2, c will be 3, c will be 4, c will be 5, c will be 6, and so on. C will become n, and then c will come back to 0, and then c will become 1, c will become 2, c will become 3, c will become 4, and so on. So what is happening in this process of length n? You have a times, like in a you have n reminders where c becomes this, and so on. M must be less than or equal to n. Okay, m value is smaller here. How to logically solve the problem. It's not a difficult problem, like, but how to just solve the problem logically. Like, what's happening here? Like, if f of I of n is like easy to see, right? What is happening? You have c going from 1, 2, 3, and so on n, and then it will go from 1, 2, 3, and so on n, and then it will go from 1, 2, 3, and so on, and so on n. So, and then it will go to 1, 2, and so on r, where r is like reminder, where r equals to modulus of a reminder n. See, length of a can be anything. We have to just determine if there exists such a thing or not, like of any length. Like, we have to just determine if any length, if there exists such a thing, such that we are going to beat this. Can we beat this score? So in number of these rounds, if you see, in all these rounds, you can see that one of them will match to p of 0, and the next thing will match to p of 1, and so on from here to here. So exactly 1. So what do you get there? You get sum of r. Everything will be added exactly once. So that is like sum of r times q plus, and if you see here, uh, vals less than or equals to r. Let me call it rem. R of x such that p of x less than or equals to this. So this is it. Okay. Can anything beat this? How can anything beat this? If smaller values of r of m, if r of 0 is like much larger than r of other things, okay, let's say r of 0 is like much larger, then you want more zeros, right? Then what can you do? uh, you will make it 0, and then you will make it 0, and then c will be 0, and then we will be adding r of 1. Let's say r of 1 is much larger, and then c is 0. You'll make it 1 0 1 0 1 0, let's say, okay, because 1 0 1 0 1 0, c became 1, okay, next time c is going to become 0, okay, c became 1, and then you got a huge r of 1, huge r of 1 compared to d. R of 1 is quite huge, and once you got a huge r of 1, that's like success, like you've already done. 1 0 is the way. And the thing is, because the length of a doesn't matter, and
The problem is keep on going. Like the problem, because length of hair doesn't matter and you can stop at any eye. You can think of the smallest length of hair where this happens. Okay, you can think of just the smallest length of hair where this happens, if it is happening, because there is an array that happens at the smallest, right? That's the power of logic. You don't know what it is, but you can just bring that down logically to there exists a smallest. If there is one, I mean that's well ordered in principle, right? If you have a non-empty set, there exists a smallest element in the set. Mm, so that's a bit beautiful if you think about it logically, right? Where am I now? Yeah, because it exists, and I'm thinking if it exists, because it exists now, there is something of smallest length, okay? And in that length, when you run the algorithm, all of the costs so far equal, will be equal or lesser. Fuck, it can be lesser. Okay. I thought of saying it will be equal, but yeah, it can be lesser. All the costs will be less than or equals to that, and then after this the cost is first time becoming greater than zero. And we have another parameter called n, which is a bit annoying, but n is also related to passing all of them, so it's not that bad. I'll go to washroom, guys. I'll think in the washroom. I hope I will think well in the washroom. We have m less than or equals to 2000. It's not a difficult problem, I just have to solve it. I'll just say the values again one more time. M less than or equals to 2000. It's not a difficult one. I have to just solve it. For collapse and falling. Okay, I think I have solved the problem. One simplification you can do is, instead of seeing permutation as P of M, you can see the permutation as uh, instead of seeing the permutation as P of M, you can see the permutation as like you can see that thing as like you can see it like you have one, two, three, and so on n. Okay, whenever the P of I is there, P of j is there, you will keep R of j value there. Else you will keep 0. Okay. So now the problem becomes like, let's just look at one simplest thing. 1, 1, 1, 1, and then like 0 came, and then 1, 1, 1, 1, 1 came. Let's just compare this with all ones. Okay. What's happening here? Till here C was moving. C is just moving, 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 moving. And let's say C came here. And once C is here, in this case C will be here, and then it will add this R of j value. Okay, now we don't have P. We have this array of R that is of length n. Okay, when once C is here, you're dropping this value, and then you're also dropping D. So what are you dropping? D plus R of j is what you're losing. But what are you gaining on the subsequent turns? From here you will start the turn now. That's just the advantage. Whereas the other guy will start from uh, the other guy will start from here. You will start from here. We both know that deep down. And then sum of R of for some prefix L. Okay. For some prefix L is this sum. This is the loss you got. But the gain you get is some prefix of L being greater than starting from here minus some prefix of L minus some prefix of L starting from here, starting at j plus 1. If this happens, then you're good. Let's say this will become greater than 0. We both know that deep down, the feeling that this deep down is good. Okay, if it is multiple of n, it's useless anyway. If L is greater than or equals to n, it's useless because only its remainder matters, because even that goes and then it comes, even this goes and then it comes back. So only its remainder matters. But remember with n, now we have to just, I think this is the answer. If there exists such a j, in this array, then you have done. Because you will just do 0 there and then once. But if that doesn't exist at all, whatever you do, you can just see whenever 1 0 becomes, the progress is decreased. Whatever happens now, it's bad. And then if you do again 1 0, it will again go back. And then whatever you do again, it's bad. So the problem is just this. It's so clear. It's like not clear, like it's highly possible. I think it's good enough proof that the answer is this now, right? That we both know that deep down, the feeling that this deep down is good. I'll put it like this so you guys can see me better. And where am I now again? So it's a quite easy problem. All it demands now is just this one. Is there this thing? Is there this thing? I think even this is not needed. Like all it demands is like, if there is a solution, the solution will be with one zeros. It's that simple. Any A's, because and for that, this is the condition. Like in this n array, the thing is n is large, but number of active things in R, that is small. Number of R's is small, and then you have to compute this. For some J, if this happens, you have to compute that. And we both know that deep down, the feeling that is deep down is good. And if R of J is 0, is there a prefix where this value minus this value is less than, greater than D is the problem? If there are many zeros, let's just try to see a prefix of L, because this is quite simpler, right? So let's try to see that, how that varies. We both know that deep down, the feeling that this deep down is good. I think, I'm not thinking anything. This shouldn't be that difficult. This shouldn't be that difficult. It's just E. It's just E. I think it should be direct from this point onwards. This is so far very correct. Like we just have to see uh, if there is a prefix for which this value happens or not. You can find these ones for everything, right? Pref of 0 of L can be easily known. L less than or equals to P1. L less than P1, it is 0. And then it is R1 plus R2. R1 for L less than or equals to less than P2. And so on. You have like R1 plus R2 and so on. L equals to N is useless. Okay. We both know that deep down, the feeling that this deep down is good. See, the existence of D makes the problem real. It makes the problem simpler because now you have to do this thing. Now, can you say something for other? See, we were able to see all possibilities of these things where we have written them here. And for this, J can be anything. J can be 0. But can we claim that J being this is better or J being far from this is better? So we have to just see 0, 0, 0, 0, 0, 0. And let's say we have some positive R here. And then we have some positive R here. I want to claim something here. I want to claim something. If J is this, what are the prefix values of these things? How are they increasing compared to if J starts from here? The prefix values of this, we want them to be lower, right? What? We want them to be lower. What do you mean by that? We want them to be So this is minus this thing. Okay. Even if you send that thing, for this 0, pref of L is definitely lower than pref of L is lower, R of J is lower than this shit, right? Because this is going through zeros. This is starting from here. So it's obvious that if you have this R, it's better to start from this 0. So now you have only M potential values for J2. So you have M potential values for J, okay? We both know that deep down. Now think of L. Now think of L. And once you fix this J, and you have to compare it with 0. You see, it's brute force. Like, there is no logic in here. It's just fucking brute force. Because this is 0, and potential values of J is just O of M now. That starts from 0. Like, that's the minimum J that gives you. The whole problem, I hope this problem is difficult, because there can be some other way where the problem is simple. Not that difficult, but I hope it is a bit difficult. Because the whole problem is splitting that P of J into 0, 0, 0, 1, 1, 1, and so on. Like, you have to bring some array that is not there. You have to remove the M, and then you have to see the bigger array of 0, 0, 0, P1, 0, 0, 0, P2, 0, 0, P3, and so on, which will give you 0, 0, 0, R1, 0, 0, 0, R2, so on. I think, yeah, that's just the problem. Like, it's like, if you just see P of J in that way, then it's like quite obvious that C is just going, and then this is like, it's quite a direct problem. Now I have to believe in my golden rules of implementations are simple. Like, I have to just come up with a simple implementation before I go to start implementing it. So I will brute force this J. So it's always better to start from J, which is like just after some R value. Okay. So what my claim is, if I'm gonna start from this, I can better start from. So I will involve this, and I will also involve uh, some R which is like 0, 0, 0, 0 before that, and this value for, because this is better than this. So I will involve both for no reason, because I'm just thinking, what if this doesn't there? Then what will I do? So if there is a 0 before that, then I will involve this. Otherwise, I will just involve this. In that way, I will only have M things at max, exact M things. And now we have this J's, potential J's, that gives us the minimum value. M potential J's. And for each of them, how many potential L's will be there is the problem now. We have seen for this L, the number of different lengths that actually matters, where the value changes, is O of M, because these are the L's where the value changes. And for this fucking thing, for this thing also, there will be only some L's where the value changes, right? There are only some L's, because for this is the first L where the value changes. And then that is the other L where the value changes, and so on. So you have all the L's where this value changes, and you have all the L's where that value changes. So you just involve union of all of these things, and both of them are like increasing values. Increasing values, increasing values. If you're taking union of both of these good L's, and then if you just brute force over them, if you just check them, it is done. M squared done. So fucking stupid brute force problem. But I have a problem here. The problem is, find the good L's, and then the problem is done. Start from some J, find the good L values. How difficult is it to find the good L values? If this is the J, what is the good L? The next R index, the next P of J minus this J, that is a good L, and so on. So you have all the good L's. From here, whatever the fuck that length is, like if I start from L equals to 1, we both know that deep down, the feeling that this deep down is good. R is not even negative. And once I have those good L's, how easy is it for me to compute the sum from here to here? The sum from here to there would be once you know the L, the sum would be uh, I immediately want the sum. I have all the L's, right? I'm thinking, is there a simpler solution? Like, I have all the L's, okay, where the value matters. I think sum is easy. Like for this J, I want to get the sum of this L things, right? What should I do then? In log n, I can immediately get the sum of this thing from the beginning. Minus, I can just do the sum of this thing. And then if it is greater than or equals to that, I have to just find the sum of this thing too. L is less than n. Without log n, can I get the sum is what I'm trying to think now. M square log n, will that work? M square log m. Log m what? Log m is like 11. 11 times 4, 1, 2, 3, 4, 5, 6. I think this might work. I'll just implement that and then I'll think about how to optimize further. I'll just get an TLE there or accept itself. It's like 2m square log m. But 2m square is also possible because it's only increasing. I will clearly say that we have two values and L is increasing. I will clearly say that in this position of L, this value will take summation greater than or equals to 0. And then at this position of L, you have to add summation greater than or equals to 0. And then at this position, you have to add summation greater than or equals to 0 to this. So you have that. And for this, at this position, I have to add summation greater than or equals to this for this value. And then at this position, I have to add summation greater than or equals to this value. So I have these unique values where I have to add these things to get all the values. And now I'll go into this thing, and once I come here, and then I will just add. I'll keep increasing L's, and then I'll just see for each L, when you go to a new L, if that L is involved in this, you will just add that. And then if that L is involved in this, you'll just add that. And then you go to the new L among one of them itself. And then you will add that. That's also O of n. That's just O of m. We both know that deep down, the feeling that this deep down is good. Okay, this is a very clean solution that I'm having in mind. To make it more cleaner, you have a J, you have this 0. Where all you will add L. For what values of L you will be adding values, you will just try to see. Okay? And then you have initial value 0. After at this L you have to add this. And then at this L you have to add this. And then at this L you have to add this. And then at this L you have to add this value here. And then at this L you have to add this value here. And then at this L you have to add this value here. And at all these L's I will compare. It's quite clear to me. The fuck I have to do is quite clear to me. We both know that deep down, the feeling that is deep down is good. So wherever you start, okay, wherever the R of J you start, if it is a zero, try to go behind as you can. Is the best thing you can do. If it is a one, if it is this either from here or try to go as behind as you can. Is the best thing you can do. Then you fucking have it. Feel that deep down, feel that deep down is good. So you have zero. So maybe from one, and then for each of them, this is the better thing. If two things are consecutive, this is the better thing, right? I'll try to add the indices of the next thing for everything. Like if you have a value here, the indices of the next thing. If two things are consecutive, the next thing will get added anyway. So that's just it. The indices of the next thing is what it is. It's what it is. So now we have good indices for J. And from here, what we should do is we have to compute all the L's, and at that L, what value will be added to this thing. Okay? We both know that deep down, the feeling that this deep down is good. For this j, you need first L greater than or equals to j. Okay, first P of I greater than or equals to j, you need that. And then you will know that, you will know that, you will know that, you will know that, you will know that. And then you can just go over everything and then you can add everything and then you're done. We both know that deep down, the feeling that this deep down is good. If I can see through walls, I can see you faking. I'll just get add one. At what L, what value will be added to the first index 0, first index 1? At what L, what value will be added to the first index 1 is what we are saying here. Okay, it's quite simple. At P of j, you will add R of j. That's what you have. This thing, you have this, you have that thing. Now you have to do it for this thing. Okay, first I will find the index where which is greater than or first thing that is greater than or equals to j. Okay, because it's non-empty, there is something first thing that is greater than or equals to. If there is nothing, that will become m, and then it will become 0, and then we'll add that, and then we'll do this. Okay. Fuck. If I can see through walls, I can see you faking. So started from 0, as long as the value is less than that, less than j, you're doing. Now it is greater than or equals to j. From here, you have to start until it is m. You have to go. Okay, these are the things that are after, right? While I less than m. Now these are all bigger things. Okay. Now these are the things to be added to j. At what values of L we're gonna see. I'm liking what am I doing. I'm liking what I'm doing. Yeah. This is the I before j, but after this you have to add what is this length? P of I minus j plus 1, comma, R of I. This value will be added there. And then I plus plus again. So now you have moved all of them and then you are at m. Now definitely I equals to m. Now what should you do? You have to make I equals to 0. And then while P of I is less than j, whatever you have ignored here, you gotta add them now. So far the length is n minus j plus 1. So far this is the length. And now you're starting from here. And from here, whatever is p of j, that will be the added length. Okay. Now you make I equals to 0. And then while I less, can I just do p of I less than j? If I can see through walls, I can see you faking. If you can see my walls, You will see your faces, saving my rental. I'm trying to cover these things, okay? Now we have add j of our thing too. Like if you start from this j, that's how that those are the L values where it will be get added. Okay? Those are the L values it will get added. So now what will I do? It's quite simple. If you just keep things clear, it's like quite simple. Like what you have to do is always quite simple. Now I will try to get all good L's here, okay? What are all good L's? The L's in here and the L's in there, right? Those are the good L's, right? It max 2L. So I don't want to sort now, but should I sort now? Feeling that this deep down is good. If I can see through walls, I can see if I can. Okay, I need not go in this order, right? IDX0. Now what will I do is, I will go over add 0. I'm going over the else in this. I'll check for all of them. Or add one. Far fallen. So IDX1 is a pointer on add one itself. IDXJ is a pointer on this itself. And okay, in this case, I only want IDXJ here, right? Because one, I'm anyway going over one. And for all these things, I will be knowing one's current value. And then I will also know this one's current value. And then I can just compare them and then I can just check them. Required equals to D plus. This is nothing but that J's value, J's actual value. If it is existing, then we have it. Otherwise, we don't have it. Fuck, I have to be careful. If I can see through walls, I can see you faking. We want value of 1 minus value of this to be greater than rec. That's what we want, right? Val 1 equals to 0. Val j equals to 0. Okay? We have IDXJ. That says when we have to do this. So we are going over L now. Okay? We are going over else of this thing. It's quite simple. Very, very simple. all of them have been added, and then you have the values of val1 and val j. So now for this L, where 1 is important, I'm just trying to compare this thing. If val1 minus val j greater than rec, greater, done. Now I'll do the same thing again. Int idx1 equals to 0, val1 equals to 0, val j equals to 0. For auto f, instead of putting them together and then sorting, I'm just iterating over that, and then I'm again iterating over this. Both of O of m, both are O of n, and j. Int l equals to f dot first, add equals to f dot second, but now I have to add this to val j plus equals to add. And then what should I do is same similar thing, while idx1 less than add 1 dot size of and add 1 of idx1 dot first less than or equals to l, val1 plus equals to add 1 of idx1 dot second, idx1 plus plus. We both know that deep down. We brute forced all the possibilities, like there was nothing. And if you're gonna do more zeros, you're gonna fuck. You're gonna fuck yourself more. Please, you could have passed, right? You could have passed, right? Let me debug it. I'll solve one more. I will not waste my time here. So it's telling us, but how is it no? It's no because the array we have is like n equals to nmd, right? N equals to 7, so which is 0. Oh, the array value comes like pr. Okay, that's fucking wrong. So I'll do that now. See? See? We don't force it well. We're gonna submit it clean. Go of m square algorithm. Precisely 2m square or 3m square. We both know that deep down, the feeling that is deep down is good. If I can see through walls, I can see you faking. If you can see my walls, you will see your faces. Saving my rental. Oh, wait a minute. Did I miss p of j equals to n? No, I haven't. If there is something before that, that plus that would be covering that. And if there's nothing behind that, one is already covering that. Oh, I see something. Once you have j, you have to start from j plus 1. Or, yeah, I have to start from j plus 1. So, I have to do j plus 1. I have to start from j plus 1. So, until j plus 1, whatever is there, start from j plus 1. From here, you have to see. From here, okay, now this is the j where you have removed it, and from j plus 1 it starts. Right? From j plus 1, you have to see that, because see in my diagram, I clearly very well wrote that after removing j from here, you have to have the same values. See, j plus 1, this sheet is j plus 1. Uh, 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 so, as long as before j plus 1, yeah, that's gone. And from j plus 1, you have to start. And then from j plus 1, what happens? So, from j plus 1, that would be the length, right? That would be the length from j plus 1. And then what happens? From j plus 1, this would be the length, right? This would be the length. What if j is n? What if j is n? If I can see through walls, I can see you faking. If j equals to n, if j equals to n, then j plus 1 will be same as 0. It can never do better than this, right? It can never do better. Both of them are same. Because j equals to n, so you have to start from here, j plus 1. Both of them are same, so that can never do better, because r is greater than 0, greater than or equals to 0, and then it cannot get greater than 0 by using the same difference subtraction. 0 cannot be greater than or equals to greater than 0, right? 0 cannot be greater than non-negative, right? uh okay, that's an error. I hope that's just the error. And then we have j plus 1 again. So now what is this? This should be j. Yeah, this is j, because that's what we are removing. And then if I can see through walls, I can see you faking. This is perfect solution. Did I mess up any j plus 1? No, j plus 1 is clear. Started from j plus 1, crossed everything before j plus 1, you just crossed them, and then you came something greater than or equals j plus 1. From then you're just adding all the lengths, and then you went to the end, and then you started from before everything less than j plus 1, you have added the values, and then you're done. If I can see through walls, I can see you faking. I should have been more careful here. I should have been more careful. It was from j plus 1. One unnecessary wrong answer. But if it gets accepted, I'm cool with that. I'm chill with that. Logically, I think it can get more difficult. If I can see through walls, I can see you shaking. So you guys think I'm a newbie, right? But I'm not. I'm as smart as I ever was, if not more smarter, because I'm not wasting my time on shitty problems, right? Okay, we are not giving up anywhere, because some problems can be solved much quicker if you have the hope in you, and if you're actually present, sometimes they can be solved very quickly. We cannot say, we cannot judge problems in a random way. So I keep trying. I'll try till the end. You're given an integer k and a matrix b with n rows and m columns. The element in row I and column j is denoted, but you guys have to see that Code need not involve any data structure. See, it's just pointers. Like I'm just maintaining a pointer, I'm just moving it. It is like clarity. You guys never understand how important clarity is. Like it's all about clarity. Like if you have good clarity, you can do good in coding. So you guys have to aim for clarity. Like I always aim for clarity. Like I don't even care if I solve a problem or don't solve a problem. I want to know what happened actually. Like what have I done, or what I should have done. Some of you may solve a problem and not even care about how you solved it or why you solved it, because you just think if I do practice, I'll just solve the problem. But you should have clarity, otherwise you think you lost the touch. See, I haven't lost the touch. I don't need touch because I know that some intuition comes from practice, but that's why I'm fucking up my contest, right? uh, you're given an integer k and a matrix V with n rows and m columns. The element in row I and column j is denoted by vi comma j. SL x comma y is called peak if it is greater than or equal to the sum of values in all other cells in the row x and column y. So I not equals to x. Okay, it's called peak if it is like greater than sum of everything else. May perform the following operation any number of times. Choose four integers xl, xr, yl, yr. Subtract one from this. See, you have to just see the problem. Okay, find the minimum number of operations required to obtain a matrix with at least k peaks. So you have to just sit back and see the problem well. Okay, because most of the times it's about seeing it in a nice way. In problem E, it was all about keeping this piece in 0 to n number line, and then keeping zeros elsewhere, keeping r of 1, r of 2 in the number line, and then seeing that c is just increasing, c becomes 0. One is just going linearly, other thing is coming to 0. So the thing is, once it comes to 0, is there a way where this will become bigger? Because if no, again coming to 0 is again bad, again coming to 0 is again bad. So it's like quite obvious direct one once you see that in a n position number line. So have to just see the problem well. You have some values, you have some operation. You have to see the operation well, because that's what the problem is all about, right? Choose four integers. Okay, subtract one from the whole square. That's what you can do. And you want peaks from this. If you see, with this operation, we can see a transformed array. Okay, let's see a transformed array where the transformed array b of x comma y is just b of x minus this value. Okay, the transformed array will be mostly negative, right? But the problem is equivalent to seeing that, because I think it's equivalent. Maybe if we have that, at least for what we have to do, I think it's equivalent, because the operations are uh, with these operations we can see how that array will transform for everything. And then, but it's not transforming that easily, that's simply just transforming in a quite complex way. But seeing that is good, because in that array you want greater than or equals to that many zeros. Okay, but the operation becomes more complex in that array. In that array, if you see this one, what is happening to some cell inside, it will be getting its value will change by -1 is being added to this side, minus of n minus 1, n minus 1. So inside what will be added is if I can see through walls, I can see you fading. inside the square. What is happening inside the square? Minus 1. So we are seeing a new array, which is u of I of. If I can see through walls, I can see you faking. This is u. What happens to u? See, minus 1 is being added to here, minus of how many different y you have here in the square. Let the square be L, not rectangle. Let the rectangle be p comma q of dimensions. P minus 1. Things are getting minus 1, so it will be like plus p minus 1 plus q minus 1. If I can see through walls, I can see you fading. See, the thing here is the problem is equivalent. If you see in the array U, in the matrix U, even if you see in the matrix U, the problem is equivalent because they could have given the same problem, this problem, and they could have asked the same question. Minimum number of operations to find peaks. So let's just see the transformed operation itself. So we have these four things, right? You have this bigger matrix, and then you have this square that you're choosing. Okay. Here is inside. Horizontally aside, I will write that. Horizontally aside will happen. This is P, this is Q. Okay. It is getting plus Q plus 1 plus Q. Vertically aside is getting plus P. In one operation. Others get plus 0. And your goal is to make them Wait. Why should I do minus q minus 1 again? I have added the minus 1 here. And then you're having plus q minus 1 plus q minus 1. Yeah, it's plus q minus 1 itself. And in this u of x comma y, is there some structure? Or these values can be completely random? That's where the bijection helps actually. I think that's where there is more logic. I cannot do the entire transformation because I haven't proved there is a backward bijection, right? Without that, this u of x may have some properties which I may be considering as completely random, but it may not be completely random because it definitely has some properties in there, right? I think it has some properties. What are those properties? Uh, what are those properties? Always, it's like most of them are negative. You have to make one thing bigger than everything else. That's only then it becomes big. Let's say these are the k things you're trying to make them as peak. Then you will have these rectangles to be subtracted. If I can see through walls, I can see you faking. If you can see my thoughts, you will see your faces. Saving my rental. There only be one peak per row and one peak per column. Right. Some lower bounds are At least that should happen. For x comma y to become a peak, because any of this and any of this cannot be involved in the same thing, because then this will also be affected and that's for no use. So this separate, this separate, this separate, this separate, all of them should happen separately. I think that's what the problem is about. I guess there's something nice in that, that they have to happen separately for this to become a peak. If you find these values for all points, one lower bound for answer is kth smallest value in this. But obviously k should be less than or equals to minimum of n comma m. This is a lower bound because assuming that all these are somehow helping each other and then becoming the max. Will that always happen? Try to see if that will always happen or not is what I'm trying to see. If I can see through walls, I can see you thinking. If you can read my thoughts, you would see your faces. Safe in my rental. Mm-hmm, mm-hmm, mm-hmm. Right. Is this lower bound possible? Is there a structure for them? Hi guys, watch my videos, my other important videos. Okay, you guys should watch my other important videos. Okay, there is divide and conquer explained in the best possible way. If I have to put a price on that, I will put around. It's temporary. Don't worry. I'll put around. I just did it for fun. Like, if you guys hate temporary tattoos, I can't help that. Talking to myself. Is it similar to jerking off? I don't know. I don't like seeing my face because I wish I was prettier. I wish I was handsome. I wish I had some handful of bitches. I'm joking, I have them already. Where am I? That's a lower bound, but to do this, let's say you have these two things. Those are becoming peaks. You cannot involve this and this together. You cannot involve them, right? Am I thinking? I'm not sure if I'm thinking, but one dot fancy helps me, I think. See, it should not be that difficult, but why am I thinking it's difficult? Why am I thinking it's difficult? F should not be that difficult because it's due to F, right? If k equals to 1, this is precisely the answer. If k equals to 1. Yeah, that says a lot. Wait a minute. I think I left my consciousness in a sixth dimension. Take maximum. That's always bigger than everything, right? Reduce all these things, reduce all these things, reduce all these things, reduce all these things. Nah, 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 nah. Nah, 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 nah. Oh, that's already maximum, right? Yeah, yeah, yeah. Ah, no, 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 no. Then this is also wrong, right? We need at least this many, but we need even more. Far, far, fallen. This is all bullshit. It's not giving us anything. I was just, this will only give us the fact that you cannot improve them together. Oh, Wait, this thing is stupid. Oh, I'm not showing my screen. It's wrong that there can only be one peak. There can be many peaks too, I think. I think there can be many peaks. Because if all of them are minus one, all of them are peaks, right? If all of them are negative, all of them are peaks, right? Seven my rental. If all of them are like brought down to minimum value, like minimum minus one, then all of them are peaks. Minus same value if you bring all of them to minus of same value. So my understanding of peak was a bit wrong because it's not like all of them are positive integers, right? It's not like all of them are positive integers. To make one thing less than, you can just keep on harassing these things, take them to most of the negatives, then all of them may benefit. Seven my rental. Now it's a good problem. It's definitely a good problem because K can be anything till n into m, right? So there is something, some structure, something that makes it very easy, very simple. But I cannot get it in 7 minutes, so I'm ending the stream. I have some other important works to do, I guess. Bye bye, guys. I hope I am getting positive because I keep getting negative. I think I do. I think I did good, but then I'll be having negative. Last contest, I thought I did good because I have done D. Oh, see, I have done E, so I thought I did good. So I have done D2, so I thought I did good, but then I got a very bad rank. It is like quite simple, but implementation like Kira has done even FE, so that's a bit bad that I'm being too bad compared to him. But this is scam. I read C wrong. I think it's a good problem, like because K can be anything and still you can prove that this is the optimal. So it is definitely a good problem. Like there can be negatives too. So now you have to think that there can be negatives and how it can make it like this. Okay. If I have to guess a simple solution, I'll guess the fact that among these values, okay, among these values, because with one operation, you can increase a lot if you're inside the square or if you're outside the square. Oh, oh, oh. Oh, if N or M, it's obvious here. The fuck? It's so obvious here, right? Oh, if N or M is greater than or equals to 3, okay, then you can see. Ah, you have to underestimate these problems. This is an obvious fact. I don't know how I was not able to see that this is much bigger than this, and then you can just make P equals 10, Q equals 10. I thought that's too trivial to be a correct answer, but problems are just like that. So you have to see now. Greater than or equals to 2, is it? See? If one of them, if P or Q is greater than or equals to 3, let's just make both of them greater than or equals to 3 because otherwise I have to worry this may give better than the other thing, right? Okay, if N and M are greater than or equals to 3, then it's best if you Take the whole thing. Ah, in this all of these cases, it's done. It's too simple. The other cases, I think those are the real problem. When one of them is less than two is the real problem. Then you have two things. I think then you can solve the problem. It's a nice problem. I should have done this, I guess, somehow. How did I miss this thing? If both of them are greater than or equal to, because see, that's giving everything biggest positive, and you will get n plus m minus 3. See, in other cases, you might have at max gotten plus n. At max, this. On others are 0. So you have to just increase, decrease everything, decrease everything, decrease everything is the best one you can do. Ah, it's so simple. Why did I miss it? How did I fuck it up? Now you know the answer, right? With this is the improvement, and you have negative values. You want to make them positive. Okay, take smallest k things. Okay, you'll have the value, and then how many of n plus m minus 3s you have to slam on top to make it to come about greater than or equals to 0 is the problem. This is quite simple. All that is left is n less than or equals to 2 and m less than or equals to 2. All that is left is this thing. Ah, everything sucked back then. Okay, but I have to still solve this problem, right? If I'm not okay, let me try to understand the complexity of this problem. If it is too simple, then I have rested the problem. But if it is not that simple, then if n equals to 1, maybe let me think about just that one. Okay, you can take anything and then you can just reduce them by 1 minus 1. If n equals to 1, is it always better to take the whole thing again? Because if p equals to one of them is 1, if okay, let's say p equals to 1. If q is greater than 3, it's always better to take everything. If q is greater than or equals to 3, you have p. Something like that. I'll not see now. I'm ending the stream. Thanks, guys.